is the following observations were made on a three stations ABC from a boat at O with the help of a sextant. Station B and O being on the same side of AC. So the data, if we represent in terms of figure, we are going to get the angle AOB is given, angle BOC is given, angle ABC is also given, the length of AB and C is given. So let me tell O, B, C, A. It is going to resemble our question ABC from A, boat of O with the help of a sextant. Station B and O being on the same side of AC, B and O being on the same side of AC, this term is satisfying. AOB, AOB, this angle we can consider it as alpha. Alpha is given as 30 degrees 25 minutes. BOC, this is beta. Beta is given as 45 degrees 25 minutes. Angle ABC, angle ABC is given as gamma is equal to 130 degrees 10 minutes. AB, AB length, if you consider it as A, if you consider it as B, A is equal to 4000 meters, B is equal to 4995 meters. So we have to find out what is the distance of the boat from A. We have to find out this distance C. C we have to find out. Let we take it as a C. C we have to find out. By using sine rule, we can say that for by applying sine rule to ABO, apply sine rule to ABO triangle, then C, that is AO, by this angle, sine of this angle is equal to A by sine alpha. Alpha we know, A we know, AO we have to find out, and sine of this angle. This angle we have to calculate. Let me take it as X and this one as Y. So this angle is going to be 180 minus X plus alpha. So we have, if you find out X, then alpha is known, A is known, everything is known. Only we have to find out X so that we can find out the AO. AO is going to be C. So X we have to find out. Let me take this X plus Y. Theta is equal to X plus Y. That is equal to 360 degrees minus alpha plus beta plus 360 degrees minus Z. That is gamma. That is going to be 54 degrees 20 minutes. So X plus Y, we came to know it as 54 degrees 20 minutes. Let X be, X we can calculate by using cot theta 1 plus alpha sine beta secant theta divided by A sine alpha, that is equal to 2.10 in terms of degrees, 25 degrees 25 minutes 31 seconds. So by substituting this value in the above equation 1, C is equal to A is given as 4000 meters divided by sine of alpha is given as 30 degrees 25 minutes into sine of 180 minus 25 degrees 25 minutes 31 seconds place alpha is 30 degrees 25 minutes. So by substituting these values we are going to get 6537.159 meters of sea, that is AO. So 6537.159, so option C is correct. So the distance of A from boat O is 6537. Option C. The question seems to be very big and the data we are going to get it from this question is going to be very high. So what is the question? How much is the active earth pressure acting on the wall? So we are not going to bother about the earthquake condition. So if the question, if you see that a gravity retaining wall is required to be designed for seismic conditions for the active state, the following data is given. Height of the wall is given as 8 meters and the angle of inclination of the back face angle with the vertical is 0. So it is going to be with the horizontal is 90 degrees. The surcharge slope angle is given as 0 degrees. So there is no surcharge. So it is going to be this is 0 and it is 0. If this we consider it as backfill, the angle of innervation of the soil, this phi is given as 30 degrees. So we can calculate the Ka, active earth pressure coefficient, 1 minus sine phi by 1 plus sine phi, that is equal to 1 minus sine 30 by 1 plus sine 30 is equal to 0.33. The unit weight of the backfill soil is given as 19 kilonewton per meter cube, 19 kilonewton per cubic meter. So the active earth pressure acting on the wall is P is equal to half Ka gamma H square. We know Ka, we know gamma, we know H, so we can directly calculate this active earth pressure, 0.33 into 19 into 8 square, that is equal to 202 kilonewton per meter. So option B is correct. The question is how much is the total active pressure including the due to the earthquake. We have to include the effect of earthquake in calculating this active earth pressure acting on the wall. We have to find out. So from the data given above, we know that the friction between backfill angle and the soil is given as the delta is given as 15 degrees and kh and kv is also given and the coefficient of earth pressure due to this earthquake is given as 0.5 in case of earthquake, and the unit weight of soil is, we know that K is 19 kilonewton per cubic meter. So by substituting this we are having a very big formula for this by considering this theta, vertical face angle, and surcharge slope angle beta. If you see in the figure, this is theta and this is backfill angle phi is given, and this is beta is 0 is given, and this angle with the vertical is 0 means it is 90 degrees. So this is the structure. By substituting all these vertical earth, horizontal earth pressure coefficient and vertical earth pressure coefficient and the friction between the soil and the backfill, we are going to get Ka is 0.5, that is directly given. As it is not possible to remember, so the earth pressure we can calculate half P due to earthquake, including earthquake, half Ka gamma H square is 8 square, that is equal to 304 kilonewton per meter. So option C is correct.